Hey folks, Steve the Math Buddha here, and in this two-part introduction to my upcoming SAT prep series, I'm going to be revealing the top 20 math topics that I found on the SATs. And for each one of those topics, I'm going to be showing you a list of all the questions that I found on that topic. And you will be able to access those questions too, because in the description below, I have a link to the site where I found those SATs. That's right, in preparation for this series, I have sorted through all the math questions on 11 past SAT exams, and I've identified 20 topics that cover over 70% of the math material on this exam. And I'm planning to teach each one of those topics in a simple, easy to follow video where I will show you all the different ways that they're asking questions on that topic. Now, if you're joining just to see the results of last week's error challenge, you will find that in the final segment of this video. But if you're planning on taking the SATs, then this video is a must-see because in a few moments I'm going to be revealing the bottom half of my top 20, topics 11 through 20. And without further ado, let's take a look at topic number 20. Sitting at number 20, we have graphs of quadratic equation. And as you can see, I've identified 13 questions on this topic, and that's over 11 exams, which comes to approximately 1.18 question per exam. Please feel free to pause this video and take a screenshot so that you can refer to the list later when you're ready to do practice questions on this topic. In my graphing quadratics video, I'm going to show you how to identify your key quadratic parameters from the graph so that you can convert it into an equation, or conversely, how to find those parameters in your equation so that you can convert it into a graph. Moving along, we have at number 19, linear word problems of the form ax plus by equals c. I have found 17 SAT questions on this subject, which comes to approximately 1.55 questions per exam. In my ax plus by equals c video, I'm going to show you how to identify the necessary parameters in your word problem so that you can build the proper equation. There will be no solving in my video. For most of the questions on this list, you don't have to solve. You just have to find the equation or explain one of the parameters in the equation. But there are a few mixture problems on this list, which is fine because I just released a video showing how to solve mixture problems without using algebra. Please find the link to that video in the description below. Next up, number 18, converting slope and/or a set of points to a linear equation. I have found 17 questions on this topic, which comes to approximately 1.55 questions per exam. Now, for the questions on this topic, you will typically be given a set of points or maybe a single point and a parallel or perpendicular line. And you're going to have to determine the slope and the y-intercept so that you can build the proper equation. And keep in mind that for all the questions on this list, you are looking for an equation of the form y equals mx plus b, except for one case where we have a vertical line. For a vertical line, the slope is undefined, and I will show you in my video how to handle that special case. Additionally, there's a couple of scatterplot questions on this list where you have to find the line of best fit. I'm including line of best fit questions in this topic if you can't see the y-axis, because if you can't see the y-axis, you really do need to use the point slope method in order to estimate your y-intercept. At number 17, we have similar shapes. I found 17 questions on this subject, or 1.55 questions per exam. In my similar shapes video, I'm going to show you how to take the ratio of side lengths between similar shapes and use that to answer questions about volume, area, and perimeter. And keep in mind as you're going through the questions on this list that any two spheres are congruent to each other, as are any two circles, any two squares, any two cubes. And also, a scale drawing is always similar to the object that it represents. At number 16, we have mean, median, and range. I found 18 past SAT questions on this particular subject, which comes out to a very impressive 1.64 questions per exam. Now, median and range come down to pretty much the same task. You have to identify specific points in your data, and I'm going to show you how to identify those specific points in a box plot, a bar graph, a histogram, or a basic chart. I'm also going to show you some cool little tricks that you can use to calculate the mean. Now, before we move on to number 15, I just wanted to take this time to remind you that if you find any value in these question lists, please share on social media. And please don't forget to like and subscribe and turn on those notifications so that you'll know when these SAT videos are released. Now, I purchased something really cool recently from Zazzle that I wanted to share with you. Check this out. It's a math clock. Have you ever seen one of these before? Instead of the numbers from 1 to 12, we have instead mathematical expressions. So down there in the sixth position, instead of a 6, there's a 3 factorial, which is a mathematical expression that is equal to 6. I really like this clock. This was my favorite one on the site. I love that picture of Newton in the background and also this supposed wood frame, which I'm not sure if it's wood, but it's a really nice frame. And in the description below, I have a link to the site where I bought this actual clock and also a link to the general math clock search page where you could find a whole bunch of math clocks. Check them out and see if you like any. As usual, I also have links in the description to the Zazzle site where I had this t-shirt printed and also to the Fiverr page of the artist that created the design for this t-shirt. Now, if you're going to buy anything at either one of those sites, I would love it if you used my links because you know what? It really does help to support this channel. And with that, let's take a look at number 15. At 15, we have factoring quadratics. 19 questions I found on this subject, or 1.73 questions per exam. Now, the questions on my factoring quadratics list come in a few different forms. In some cases, you just have to solve a quadratic by factoring. Other times, you might have to reduce a fraction by factoring. And I actually have a couple of fourth-degree equation questions and a couple of third-degree equation questions on the list. I'm including those kinds of equations if they fit a particular form. Note, in the first case, if you set y equals x squared, you have a quadratic in y. And in the second case, you can factor an x out of your third-degree equation, and that will leave you with a second-degree equation. In my factoring quads video, we're going to look at all these different types of questions, and I'm going to show you how to solve them. Sitting in the number 14 position, plug it in and calculate. 19 questions I found on this subject, or 1.73 questions per exam. Now, the questions on this subject are exactly how they sound. You're going to be given some expression, f of x equals, and then they're going to ask you, what is f of 2? Now, most of your expressions are linear, but there are a few cases where you have to plug x into an exponent. There's also a couple of quadratics in this list, and a couple of cases where you have to do 2 plugins in order to do your calculations. But in the end, you're just plugging in a number and doing a calculation. Next up, number 13, comparing statistics of 2 data sets. 22 questions, or a whopping 2 questions per exam. Now, for most of the questions on this subject, you're comparing 2 data sets that are very much the same. Either you're adding a data point or 2, or you're removing a data point, or the numbers are just shifted a little bit. In the end, you're going to have to determine how those changes affect the median, the range, and the mean. And I'm going to show you some nice little tricks that you can use to do that. Sitting in the number 12 spot, we have linear graphs. I found 22 past SAT questions on this subject, or 2 questions per exam. In my linear graphs video, I'm going to show you how to convert the graph of a line into an equation, and conversely, how to convert a linear equation into a graph. We're going to be dealing with the y equals mx plus b form and also the ax plus by equals c form. And I'm going to show you some nice little tricks for dealing with the ax plus by equals c form without having to convert it first into the y equals mx plus b form. I'm also going to show you a really cool way of building a linear equation directly from the x and y intercepts. At number 11, we're looking at solving linear equations. 23 questions on this subject, or 2.09 questions per exam. Now, the questions on this list are simple linear equations in a single variable where all you have to do is isolate the variable on one side and do all the work on the other side. Now, there's a few questions on this list where at first glance they don't seem to be linear equations in a single variable, but they reduce to linear equations in a single variable after doing a plug-in or 2. So that's topics 11 through 20. Top 10 will be coming out a week from tonight. I truly hope that you found the information in this video valuable. Now, I have not yet decided how often I'm going to be releasing these SAT prep videos. There's a lot of stuff that I want to do on this channel, and where I invest my time really depends on what you all want to see. So let me know in the comments. Do you want to see more SAT prep? If so, I could push everything else aside and just focus on the SAT prep. I am here to serve you. This channel is nothing without you. Now I'm trying to smile more in this video. You might have noticed it in the introduction and also in the call to action segment. And it's not just this video either. I'm trying to smile more in my personal life as well. It's amazing the reaction that I get when I simply flash someone a smile. And if I'm going to talk the talk and call myself a Buddha, then I really do need to embrace this central concept of Buddhism. Our greatest source of happiness comes from our desire to see other people happy. And there is no easier way to make somebody else feel good than by simply flashing them a smile. It costs us nothing and it gets us everything. And with that thought, it is now time to reveal the results of last week's error challenge. You might recall that in last week's video, I issued the following error challenge. As I was splicing together the clips of this video, I noticed that I made a mistake when I was filming one of the clips. A mistake that led to a clear continuity error. Clear evidence that that particular scene had been shot out of sequence from the one that came before it and the one that came after it. So where is this continuity error? Well, let's take a look at 349, and let's pay particular attention to that left wrist. Do you see anything interesting about my left wrist? That's correct. There is nothing notable about my left wrist at 349. So let's take a look at 652. What's that? A watch suddenly appears. And finally, let's jump ahead to 1054. And it's gone. Just like that, the case of the appearing and disappearing watch. So that was the answer to last week's challenge. For this week's error challenge, you might have noticed that there was a point in this video where the text on the whiteboard behind me suddenly changed, and then a few minutes later, it reverted back to its original form. Did you notice it? Let me know in the comments what you saw, and as usual, I will reveal the results in next week's video. And that's all I've got for you today. This is the Math Buddha signing off once again, and reminding you to smile at the next person you see. Good night, folks.